Hello. Okay, let's share screen and let's talk about animals. Okay. Animals. Let's talk about what exactly is an animal. So you have to make sure you understand the definition of what an animal is. Okay. So this is what an animal is. Okay, as far as we understand right now, first animals arose about 570 million years ago. They probably resemble aquatic protists. Then clinophagiolates, which I'll show you in a little bit. Okay. The first era of animals was something called the Carnians. So this is from the Precambrian era. So you can see some things look very similar to animals, but some things look very similar to plants and stuff. So you can see these guys here, they're really simple animals. Okay. Um, so most of them animals actually originated in the Cambrian. So the next era is called the Cambrian era. Um, okay. Animal diversity reflects shared ancestry. So we can so again, these dots are where I'm going to make sure you guys really understand the evolution of multicellularity. That's animals, and then you have animals with true tissues and animals with no true tissues, and also sponges. Okay, from the class true tissues, you have radially symmetric animals like jellyfishes and bilaterally symmetrical animals and everything else, and then uh, from there, you have deuterosomes and protosomes, et cetera, et cetera. Okay. And so we'll basically your exam will show like understanding of every single one of these little dots and not all the little details. Okay, so I'm gonna skip forward and we'll come back to this chart, but it's easier to go forward and talk about what all these animals actually are, and then we'll talk about um, what they mean. So the first step are sponges. Okay, sponges are really simple animals. They look like sponges, and these are the baseline here, right? So they have no true tissues. Okay, they're multicellular organisms, but all they are is basically a hollow circle in which water flows in, and whatever's in the water they eat. Okay. Okay, so they float their feeders. Okay, the next group of have true tissues, and they are radially symmetrical. So radially symmetrical means they're circular. Okay, being circular means they usually have no head. So like jellyfishes don't really have a head, stuff like that. Okay. Okay, there are four groups of Nigerian jellyfish, hydra, coral, and sea anemones. Okay, they basically have a very incomplete digestive tract. So they have one big hole. They eat and poop through the same hole. So whatever they eat, once they're done with it, it comes right back out through the same hole. Okay, and they have um, two different structures: a polyp and a free swimming medusa. Okay, so okay. Next one up, okay, are have true tissues and they are biologically symmetrical. They're a group of animals called protozoans. I'll explain what protozoans are in a little bit. Okay, and they're flatworms. Okay, so okay, so protozoans are actually important. So let me talk about protozoans back here. Okay, protozoans are classified by mouth development. Okay, so the gastrulus first indentation develops in protozoans. So in all animals, we develop a hole. Okay, in protozoans, that first hole is the mouth, and the anus develops later. Okay, in humans and in echinoderms, okay, the first hole that opens up is actually in the anus. The second hole is actually the mouth. Your anus actually forms before your mouth does. Okay, it seems like not a big deal, but it's a very clear distinguishing feature in these animals. Okay. 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 So flatworms are simple protozoans. They have no column. They have a flat shape. Their flat shape allows them to absorb nutrients very quickly and efficiently, and therefore they have no need of a circulatory system or respiratory system. Okay. So they have a very simple organism here. Okay. The brain and nerve cord makes a nervous system that can detect chemicals and light. Okay. And you see, as we go along the way, we're getting more and more complex organisms. Now these organisms have a really simple brain, but a brain. Okay, they have vertebral nerve cords. They have a mouth and stuff now. So they have a simple digestive tract. Okay, but closely related to um, flatworms, or these things called mollusks. I'm sure you guys are aware of what mollusks are. So mollusks have three groups, four groups, but we don't really count them because they don't really do anything. But we have valves, okay, bivalves, gastropods, okay, and cephalopods. So gastropods like snails and slugs. So gastro stomach, okay, pod foot, and cephalopod head foot. So head is attached to the foot directly. Okay. Okay. A mollusk, you can see, actually has everything. It has a nerve system and really primitive brain. Okay. Octopuses are actually measured as quite smart. Okay. Simple digestive tract, heart, okay, a circulatory system. Okay. So those are mollusks. Mollusks are actually very closely related to something called annelid. Okay, annelids are segmented worms. Okay, like the most common one you see are earthworms, but there are also things that live in water. Okay, so again, with earthworms, you start to see a really complex individual. Okay, it has a brain, it has a nervous system, it has hearts, it has a digestive tract, etc. Okay, so now here. Okay, okay, so the next group are unsegmented worms. Okay, uh, unsegmented worms are roundworms, or the other ones known as nematodes. They actually molt their cuticle, which is a big difference compared to these guys. I know it doesn't seem like a big deal, but it is. And actually, the molting of the cuticle actually puts it closer to arthropods. Okay, roundworms are closer to arthropods than they are to all the other worms. Okay, okay. So most roundworms are microscopic and they're abundant in almost every habitat. Okay, so roundworms have few organ systems, mouth, brain, intestine, cuticle, etc. Okay. So make sure you separate the three phyla of worms. Okay. So roundworms, annelids, and mollusks all share one feature. They are all protozoans, and they all have bilateral symmetry. Okay. Okay. The biggest group are arthropods. The arthropods have joint appendages. Okay. The group Arthropoda is the largest and most diverse group of animals. Okay, they have legs, antennae, mouthparts, and their organs are jointed. Okay, so trilobites, chelicerates, which are going to be scorpions and spiders. Okay, theropods, don't look at about those. Crustaceans. Okay. Okay. Make sure you understand arthropods because they literally, we humans like to think we're the best animals ever, but we are not. Okay, we pale compared to arthropods in terms of how many animals there are. Okay. All arthropods produce a top exoskeleton made out of chitin. Okay, so as their bodies grow, they molt and grow a new exoskeleton. Okay, so like they said, they have to molt. So these guys all molt, which means they have to shed their exoskeleton. Okay, arthropods are divided in 5 subphyla. One group are trilobites. Okay, scorpions, spiders, and other chelicerates have claw-like mouthparts. Okay, spiders and scorpions. Okay, the most successful of arthropods are insects. Okay, and then other ones are these are all insects. Okay. Okay. Now, last group that I'm talking about in this presentation are echinoderms. Okay, echinoderms are marine deuterosomes. They're closely related to chordates. We are a member of Chordata. Okay, this group. So out of all the things we're talking about, the most closely related things to us are actually starfishes and sea urchins and sea cucumbers. Okay. They are unusual that among animals that adults, their bodies are radially symmetrical, except when they're larvae, they look more like larval things. Other groups larvae, and they aren't symmetrical. They're bilaterally symmetrical as larvae. Somehow they turn into the shape. Okay. Okay. So the last group that we'll talk about here, I'm going to stop after these couple of slides because I want to focus on chordates. But we are a member of Chordata. Okay, so humans, shrimps, fish, etc., etc. Okay, most things we consider like animals are actually animals, but they're actually in chordata. Okay, you definitely have to notice all chordates share the same 4 features. Okay, 1 is the notochord, 2 is the dorsal notochord, 3 is pharyngeal slit, 4 is the postanal tail. So this is chordata. Okay, and again, and we'll do the same thing with chordata that you guys we did with the other chapter. You guys have to know all the splits, where all the dots on here. Okay, all right. We'll end this presentation here.